think I'll start by negating everything he just said. No, I would suggest you don't listen to necessarily what I'm saying, but maybe a couple of the questions that I want to pose. So we're talking about global engineering, and I was trying to think about what to talk to you about today. I wrote an essay about what a global engineer is roughly 1 year ago for a scholarship, and I went back and read that essay, and it's funny, it doesn't actually make quite as much sense as when I wrote it. It was a super kind of lofty vision of the perfect idea of a global engineer who's like a superhero and can do everything. And I don't think that's particularly realistic, and there's probably not a whole lot you could take away from me talking to you about something like that. So I'm going to spend 10 minutes here to give you like a simple, my kind of updated version 2 definition of global engineering. I want to give a quick idea of why I think global engineering is important kind of generally and also at a personal level, and then finish with a couple of examples of what I think global engineering looks like right here, right now at U of T, and what it might look like for a graduating engineer. So the definition that I came up with is roughly that global engineering is about having a deeper sense of purpose of what we're trying to do in a much more interconnected world. So the big idea there is the purpose is the why. I think a lot of what engineering teaches us right now in terms of technical courses is how. We learn how to solve equations, we learn how to optimize systems, but we don't get a lot of the why. And to me, that's kind of what the difference between maybe engineering, which is maybe the technical problem solving, and global engineering means. And so the question of why global engineering, I think there's a couple of things happening in the world right now and over the past years that make it a relevant theme or a relevant idea. One is the sheer force of globalization in terms of the connections between different countries, the way large corporations are operating on a much bigger level, the kind of the flow of resources, the flow of projects. Globalization is happening, and I think we don't need to just adapt to it. I think we need to be aware of it, critical of it, and play a role in the way globalization rolls out moving forward. That's one point. Number two is that there's a pretty intense inequality in our world between countries and even within countries, and there's some pretty intense environmental impacts of a lot of the different corporations and different countries and the way they're acting in the world. There's a lot of kind of large-scale problems that need to be addressed, and I think particularly for this audience here, it's important to realize kind of who we are in the context of globalization. I mean, you can read the newsletters and hear whatever U of T engineering ranked top 10 in the world, something like that. But I think the essential point to me is that the people sitting in this room, you're essentially the elite of the world. And I think if we're not aware of what's happening and how we're affecting that, that's a major problem. So that's at a broad level to say why is this idea of global engineering even important. In terms of at a personal level, I think there's a bunch of different motivations of why you want to get involved in kind of playing a role in how globalization happens. And I think it could be curiosity. You could just be curious of what's this idea. Maybe that's why you're here today. It could be more career-oriented. Maybe you've been doing your research and realizing that a lot of the engineering jobs are in big corporations that kind of span parts of the world. It could be a deeper sense of maybe altruism or wanting to help or wanting to contribute. It could be because of your background. U of T's got a lot of international students. That's not me. I'm from Ontario. There's a lot of people that come from different countries to U of T, and they naturally have a much broader sense of the world than someone like I do, kind of growing up in Ontario and going to a school in Ontario. There's a bunch of different motivations of why global engineering, and what I think is interesting is that they change as you get involved. So I would say like the turning point for me was joining Engineers Without Borders, and when I joined EWB, and some of you here in the room were there when I showed up at my first EWB meeting and ran an election for an executive, for me it was really partly curiosity, partly wanting to do more than just my schoolwork, and a little bit of this interesting idea of how could technology kind of help people who are in difficult situations. So that was why I got involved in EWB. Now that's changed a lot in the last 2 years. I would say the reason to me personally why global engineering is important right now has a lot to do with the knowledge and the experiences I've gained, both through conversations here at U of T, my experience, I was able to go to Zambia this past summer and work on an EWB project. So I got some of that first-hand connection to the people who are at the very other end of the spectrum in terms of income, and I was blown away by their compassion, their commitment, and just the way they live their life. So it's a lot more personal to me now. but the reason I got involved in it 2 years ago was quite different. So that's a bit of the why, and I want to wrap up now by talking about the what. So I gave you an abstract definition of connecting with a deeper sense of purpose, but I think like a simple, tangible way to think about what global engineering is here at U of T is to think about, I heard someone talking earlier that a lot of the first years aren't coming today because they've got a problem set due tomorrow, which is like, that's perfect. If that, I think right now is what engineering is. Engineering is like, stick your head under the sand and do a whole bunch of problem sets, a whole bunch of midterms, learn your differential equations, learn how to integrate, learn how to get whatever mark makes you happy on a midterm, but we're down in the ground, maybe even underground. And to me, the difference in global engineering is looking at that silo of an engineering and looking kind of up over the top of engineering to say, what's happening in the law faculty, what's happening in medicine, what's happening in economics, what's happening in history, and just trying to make some of those connections. Maybe it's choosing an elective that you actually care about. Maybe it's doing a thesis project or design project that connects with another faculty. And so I think on a day-to-day, within this like engineering degree that we're taking, there's two parts of that flow. One is, what can engineers do to contribute to kind of broader projects that are more than just technical? And there's a couple of things I think we have to offer. One, I think engineers are great at math, usually, if you're passing, if you're still in there. You're good at math, and you're good at kind of modeling things. You're good at taking things that happen in nature and kind of figure out mathematically how to predict what's going to happen. Another one, I think engineers are good with systems. Now, the systems that we're good at are usually technical systems. Maybe it's a chemical plant, maybe it's some kind of electrical circuit board, but we're good at taking these ideas and like visually mapping out the parts of the system and seeing how they relate. And the third thing that I think some engineers are good at is this idea of design. So taking an idea, trying to make it work, it doesn't work, make some adjustments, keep going until you get something that practically works. So that's what I think engineering can take out into maybe other faculties around U of T. And the other part is, what can we learn from them and bring back? As we get to the top of our engineering silo, there's a lot to learn about people, about psychology, about business, about international relations. There's a whole ton of stuff happening at the university that we're not exposed to, but we could be exposed to. I think if we learn from that, that's going to help us solve some of the broader global problems and not just how to optimize a plant or design a better circuit or that kind of stuff.